Have you paused the previous week? Thank you very much.
I love my job.
Hey, very enjoyable. I love my job.
So, so first of all, there will be 5 questions. So number 1, 2, 3, 4, 5. Okay. So that's number 1. So number 2 is that the first question.
Yeah, we will listen to you.
If you want to
Yeah, yeah, I'm listening to you. Yeah.
So the first question is about the kernel density estimator. Alright. So you have some data, which is IRD, and you're supposed to estimate the
Yeah.
density using the KB. Alright. And you should derive either the variance or the bias. One of them. Well, bias is short. So that's number 1. Number 2 is that you should understand what is the sort of what happens. Sure. Maybe I just do that. Maybe it's both. I can talk. Oh, that's great. Thank you very much. Oh, you were gone. Exactly. So that's the part. And then one should basically, you should also know the bias variance trade-off. And if the bias, you want to reduce it, then you decrease the range. It necessarily means that the variance will become larger. Right? So she wants to have it, she left for a home. Yeah, so that's very important that you know the bias variance because that's an important lead topic for whatever in data science. So that's number 1 question. All right. So that may be a little bit sort of. Then the second basically question that we have is about Markov models. All right. Well, what are Markov models? Why do we use them? So what is the intuition behind it? Okay, so it's important to know. I mean, if you have information about a break or a switch, then you use it. If you don't have it, then you turn to probabilistic models. Yeah, so that's sort of the rationale behind usage of Markov switching. And then let's give you some transition probability and then ask you to make some statements for this. All right, so with respect to the transitions, how many days you stay in one so that before you leave, and so on and so forth. So the stories that we had around the transition, that's important. Then you have some question on large arch. All right, so I give you some large and I ask you, so do you have the conditional or unconditional mean? Right, or do you have the kurtosis? Right, or something like that we did in the class. But let's say I have a large 1, then is it an R mark of which order? So which is an R mark 1. So that's also another sort of type of question that you have. You will have one question with respect to portfolio choice. Well, I mean, what we did was that in the class we had the Sharpe ratio and then we did the maximization. Of course, I knew that you knew it from your previous classes. Well, I didn't do the derivation. That was my point. To do the first order condition of getting involved in the algebra. Right? But let's say if I change the objective function from Sharpe to something else, then you should still be able to do the first order condition. And then make sense of, say, what are the weights, why are they high, why are they low, under this and that situation, right? So there will be some other type of question that I will ask. Okay. For example, with respect to the Sharpe ratio, last year's question was, let's say you have the expected value of the RP minus the risk-free rate divided by sigma P, and you maximize it in the base. Yes, that's the Sharpe ratio. And then let's say we have 2, right? And then we do the maximization. When you do the maximization, and then let's say W1 plus W2 is positive, 1, W1 is positive, W2 is positive. Let's say we do that, right? And then you get optimal values. So bigger than 0, also bigger than 0. So you invest in both. Right? Then the Sharpe ratio, if I want to calculate it, then I need to know what the W are. So the optimal value of the Sharpe ratio will be a function of these two. Right? That was the last year's question. So then I asked, okay, so if our F increases, then what happens to this? Will it be larger or smaller? If the risk-free rate becomes big.
Small.
Why?
Because the difference between the exactly which I see everyone.
Sure. That's a direct effect. So the F becomes larger, and then the Sharpe ratio becomes smaller. Right? But then you should also remember that when the Sharpe ratio, well, the risk-free rate becomes bigger, then the weights change too. Right? Or so to speak, the derivative. So you have to form a derivative of this with respect to the risk-free rate. Right? And then there is a direct effect. And there is also an indirect effect through values.
Yeah.
That sort of, well, these are two effects. So the direct effect is negative. You should also show that the indirect effect is also negative, and that's additive. So you have a totally negative value. But I accepted solutions which were in variable. Right? The variable answer is also okay, but some people did the derivation, like took. It was just unbelievable. He did in the derivatives on the exam. It was just so shocked about these derivations. Shocked positively. He did very nice. But then some other students also wrote arguments and then so. So if I ask, well, I'm not asking this question, but I'm just saying that last year I asked such a question. Right? Usually intuitive. Right? That's a very intuitive question. Right? If I change the objective function and I ask you to do the derivation, you should be able to repeat the questions, the objective function easy, such that we know how to do the derivation. Right? And then we will have an optimal solution and then analyze. Right? So sort of talk about that. That will be another question. To understand the interpret. And we'll also ask one question with respect to this eigenvector, eigenvalues stuff. Alright. So the exam questions are not so, well, they are not Python programming, they are but rather with respect to the understanding of the material we did. Well, I mean, but also some math is involved. Good?
Yeah.
Let's see. Thank you very much. I don't know if you recorded properly. But you take
Thầy sẽ dựng lên cho chị. Dạ, để thầy nói tiếp.